In this section, we are gonna learn about one more uh, volume method called the volume by volume by shell method, or the cylindrical shell method, cylindrical shell. Sometimes we also call this cylinders method, or sometimes we also call this is just a shell method. Why we call shell method? In this section we're gonna cut the we can split the region into shells, so it's like this shell. So we're gonna break the region, we're gonna cut the region into small cells like that, so like that, and then we're gonna find the volume of one such shell. So we only have this part, you can see we only have we have like that. Okay, so that's what we have. So we can see the shell, so like it's a hollow, there's nothing in the middle. So so we're gonna find the volume of one such shell and then add all the shells. So if you want to find the volume of a shell, what we need is the we need the radius of the shell, shell radius, and we need the height of the shell. So if you know those two, we can find the volume of this one, and we also need the thickness. So this shell has a thickness, and we also need that information. So those are the three things that we need to do a problem in this. So since we break the region into shells, so we call this a shell method. So let's try to understand why this method is important. Let's look at this example. Let's say we're gonna rotate this area bounded by this curve. So what curve? Y. So let's look at this curve. So this is y equal 2x squared minus x cube. So that's the curve, and if you plot it, it's gonna go through 0 and 2 like that, and then so what we're trying to do, we're gonna rotate this region around the y-axis. Okay, around the y-axis. So now if you try to use the previous method, for example, since we rotate about the y-axis, so we're gonna cut perpendicular to the y-axis. If you want to use the washer method, so that means your typical cross section gonna be like this. So those are the typical cross section, and then the other part is on this side. So so that's the cross section. So, and then we have the smaller radius and the larger radius. So the smaller radius is x coordinate of the left side, this is the x coordinate of the right side. But the problem is how to find them. We need to find the x and y, because you can see that the integral is the gap is dy, that's the thickness, dy, that means it's the integral of y, right, with dy means integral of y. So that means you have to integrate with respect to y, that means you have to solve for x. So you have to solve y equal 2x squared minus x3 for x. Can we solve this one for x? I mean, you can, but difficult. Okay, very difficult. So if you want to solve for x, it's not an easy task. You know, it's very difficult. It's very difficult to do. So that means we cannot use the washer method for this problem. So you get stuck. Because you want to find the two radii, the shorter radius and the larger radius, but that means, in other words, you have to solve for x, but this is a cubic equation, so it's difficult to solve for x. So that means Washer method does not work for this problem. So that means we need to discuss the new technique, what we call the cylinders method. Okay, let's call it or the shell method. So the cylinders method. Cylinders method. Cylinders method. Okay, cylinders. I call cylindrical shell. So some people call shell method, some people call cylinders method, but it's the same thing. So cylinders method. So how it works? So let's develop the theory here. So let's look at a region like this. So I'm going to derive the general rule here. Then we can discuss this. So let's say you have a curve like that. So and then we also, let's say we can rotate this about the y-axis just to make things easy. So if you do that, what's gonna happen? It's gonna rotate. It's gonna generate a solid. It's gonna go like that and go like this. So that's the. It's not exactly correct. So your solid looks like that, and then so we have this here. So that's how the solid looks like. It's gonna go around like that. Okay, so that's a solid. So and then we remember. So I'm gonna write this again. We remember when you do the disk and the washer method, we're gonna cut perpendicular to the axis of rotation. So it's a perpendicular to the axis of rotation. So that's how we cut. We had the axis. We're gonna cut perpendicular to the axis of rotation. But right now it's exactly opposite. What we're gonna do, we're gonna cut the cylinders with the exact same axis of rotation. So that's the main difference. So here we're gonna get the cylinders, but they have the exact same axis of rotation. Yeah. So see the difference. Okay, that's the major difference. They have the same axis, and then it's gonna create the solid like that. That's the inner one. That's the outer one, and again the outer one, and there's an inner one. So that's how it looks. So we're gonna cut into shells. We're gonna cut the region into shells. So now what we want to do is we're gonna find the volume of one such shell. So we're gonna find the volume of one such shell. So it looks like that. So this is how it looks like, and then the height, and we have this. So we're gonna find the volume of one such shell. It's not that difficult to find. So what we have here, so what we need the height h, and then we also need the radius r. Okay, and then you can see that. So we are going to go in the x direction. So that means this gap, this thickness, that's the thickness, is dx. So this thickness we're gonna get as dx because that's in the x direction. Thickness is dx. So the thickness is dx if we do rotate about the y-axis. That's the dx. Okay, so what's the height? As you can see, this is the height of the shell. What's the height? Height is simply the function y equal fx. That's the y value of the function. So this is simply the y coordinate, or it is simply the function fx. That's the height. And the radius. Radius is the x coordinate. You can see that's the radius. It's going to be the x coordinate in this case. In this case, okay, not in general. So here it's going to be the x coordinate. So for this kind of problem, so that's the radius. Now what we're trying to do, we've tried to find the base area, but the base area is the area of this ring, right? Area of this ring. What's this area of the ring? What's the perimeter? What's the length? That's the perimeter. So we can write area of the ring. It is simply the perimeter, that is 2 pi, if you go r, 2 pi r, and then that's the length, and then the thickness times the thickness. The thickness is simply dx in this case. It's a dx or dy depending on the situation. So in this case you get dx. So that's the, so that means the area of the ring is 2 pi r dx. So the volume of the shell, is area times the height. So it is area times height. So that means 2 pi r dx times h, that means the function fx in this case. So that means the volume of this situation is simply given by, I'm going to write in the next slide, or you can put everything in this slide. So it is simply V, the volume is, you have to find the limits of the region, so I'm going to call it A and B. So it's going from A to B, so it's AB. 2 pi r radius of the shell, and then the height of the shell, and dx. So that is the shell formula, 2 pi r fx dx. Okay. So let's do a problem. Okay, so again the cylinders formula. Equal A to B, 2 pi shell radius times the shell height. Dx, I just write dx depending on the direction. So that is the formula we have. Okay, this works for any situation. Good. So let's do some examples. So example number 1. Let's say find the volume of the solid. Remember the problem that we could not do last time? Now we can do it. Okay. Before that I want to write a few things. This is the radius, that's the height, and that's the thickness. Okay, so that's the formula. Okay, so let's go back. So let's do find the volume of the solid. Find the volume of the solid. Find the volume of the solid obtained by rotating about the x-axis, about the not x-axis, about the y-axis, the region bounded by region bounded by y equal 2x minus x cube and y equals 0 and y equals 0. So what's the region they are talking about? You need to like draw a situation for these skins always, okay? Because that's one important thing. So it's 0. At 0 it's 0, and then it's gonna go and negative, and at 2 0 again. So and then what we do, we're gonna rotate about the y-axis. So if it's a difficult curve, it's like something that hard to draw, we might give you that in the exam, okay? But if it's an easy one, we will not give you that. Okay, so we rotate, so that means so we get the shell like that. So this is a typical shell. So we're gonna go like that, height. So this is a typical shell. Yeah. So what we need is two things. We need the radius and we need the height. So the curve is y equal 2x minus x cube good. So we have everything we need, and then you know that this is the x coordinate. So let's find the information that we need. We need the radius. What's the radius? Radius is because what we do, we're gonna cut the shells with the same axis as the axis of rotation. Okay, so that's how we cut the shells like that. So the radius is x, and the height is the y coordinate. That's the height. So which is 2x minus x cube. So we have everything we need. Okay, so the volume is okay. What are the limits? It's going from 0 to 2. 0 to 2, because what we do, we slowly change x. Once we change x, it's gonna go through different cells, and it's gonna cover the whole region. That's what happens. So we're gonna start with 0 and consider larger and larger shells. So it will sweep through the whole region. So that means x changes from 0 to 2, and then so the formula is 2 pi. The radius is x, fx dx. So we're gonna plug in them here. So 0 to 2, 2 pi x. Fx is 2x minus x cube dx. This is a very easy integral. You can take 2 pi out, and then we can multiply through. So you get 2x squared minus x to the 4th dx. It's a very easy integral. So the integral is 2 pi, what do you get? 2 pi, so you're gonna actually, I think I made just a little typo here. The graph has to be what was that? Yeah, that was x squared. Actually, there was another x missing. This will be x squared, so that means this also has to be squared. This is squared, so this is squared, and so this is gonna be 3 now, not 2. It's just a different graph, so you might get a slightly different graph here, but let's fix it. So this is 3. Good. Okay, so that's what I have. So this is what you can find in the textbook, so it will be easy for you to look at that later if you need more explanation. Okay, so then when you integrate it, so you divide by 4, so that means x to the 4th divided by 2 minus x to the 5th divided by 5th, and then you put 2 and 0, and then you say 2 pi. If you put 2, you get 16 over 2 minus 32 over 5. If you take the common denominator 10, you end up getting, after simplification, 16 over 5 pi unit cube. Okay, so that is the volume of the region, but you can see that this one we could not do before, but now using the shell method, you can easily do it, and you can also see that the integral is very easy. But just imagine if you want to find the washers, it's going to be very, very complicated. But this method is very easy. It's not that difficult. Okay, and the integrals also going to be very easy because it's just a simple multiplication, and then after that you can just integrate. Those are easy integrals. Okay, so let's do 2 more examples. Let's do 2 more examples. How about this one? Example number 2. You can see, find the volume of the solid. Find the volume of the solid. Find the volume of the solid obtained by rotating. Find the volume of the solid obtained by rotating about the y-axis. The region between y equal x and y equal x squared. Okay, so we have the region between those two rotate about the y axis. Those are all important. So let's draw the situation. So we have y equal x and y equal x squared. Okay, so they meet at a point, and then we rotate this region about the y-axis, and if you do that, so it's gonna go like that, and also it's gonna go like this. So that's the region. So what we gonna do is we're gonna cut this into shells, but we can see when you cut it shells, you only get this part here and the part there. That's what it looked like. Then the same, yeah. And then if you draw the shell, this is how the shell looks like. Okay, the outer one and the inner one. This is how it looks like. So so what you need is you need the shell height h, and you need the shell radius. Okay, for the intersection point, what we can do is we can set them equal. Intersection, you set them equal. X squared equal x squared minus x equal 0, x minus 1. This says that x equals 0 and x equal 1. So it is 0 and 1. Those are the two values. So that's going to give you the integration limits. And then what else you need? You need the cell radius. So what's the cell radius? Cell radius is the x coordinate. cell radius is the x coordinate value. Okay, so the radius equal the x coordinate. The height, what about the height? Height is the difference in the two y coordinate, right? So we have y equal x and y equal x squared, the top minus the bottom, so that means the top one is x, the bottom one is x squared, so that's going to give you the height. So that means we have everything we need. So the volume is simply is going from 0 to 1, 2 pi x, that's the radius part, and then we have the height, which is coming from x minus x squared and the dx. So this is a very easy integral. You can take 2 pi out of the integral and then multiply through, so you get x squared minus x cube dx. So it is 2 pi, the integrals are x3 over 3, x4 over 4, 1 0, and if you plug in 1 and 0, 1/3 minus 1/4, that means 1/12. So with that 2 pi over 6 unit cube. Okay, so that's the complete problem. So you can see those are simple, it's not that difficult. Okay, good. Let's do a different one. Let's do the other way. So this is example number 3. So use shell method or cylinders method. Okay, so it's not working. Use shell method to find the volume, of the solid obtained by rotating the region under the curve y equal square root x from 0 to 1 about x-axis. Okay, so what it is talking about, so you have a region between this is y equal square root x-axis from 0 to 1, rotate about the s-axis. Okay, so want to rotate, that's what you get. And then what do you do? Remember we have the shell centered at the same axis, so that means you're gonna get a shell like that, and then so that is the shell radius is always from the axis how far you go, and that's gonna be the shell height and the shell radius. And then also we know that so we're gonna pick a point on the x, so that's the x coordinate, this part is the x coordinate, that's the x coordinate. So we have height. Let's go with the radius first. So we have the radius, okay, radius is measured from the axis of rotation. So how far? R. So this is radius R, but it is simply the y coordinate now. Simply the y coordinate, which is a y coordinate. You can put x squared, but let's see whether we need to turn it or not. So that's that, and then also the height. Height is what? Height is h, but what is that? So that is the total length is 1, so we have this is 1. So this is a different situation. So this is 1, all the way 1, but you have to subtract x from that because this is x. So that means it is 1 minus x. Okay, 1 minus x. What is x? What is x equal to according to the curve? Because y equal square root x, so x equal y squared. So it is 1 minus y squared. And also, you know, the thickness is dy now. The thickness is dy. That's the thickness, which is dy. So it's not a dx problem, it's a dy problem, because your shell is like this. This is how the shell looks like now. How it looks like. So so that's how it looks like, because you are rotating about the x-axis. Okay, so we have everything we need now. This is a simple integral again. So we get the volume, which is okay. So value of y going from where to where? When x equal 1, y equal 1. So it's going from 0 to 1, but these are y values now. So it's a 2 pi. The radius is r, but r equal y in this case. And then the height. What's the height? Height is h, but h equal to 1 minus x, or 1 minus y squared. And the thickness is dy now. Okay, so again this is like easy integral. So you can take 2 pi out, and then 0 to 1, y squared minus y cube. We did a similar integral before, and then after you finish the integral, you should end up getting pi over 2. So the volume is pi over 2. Okay, so I hope this is clear, but be careful here. The height is now the height is along the x direction. Okay, so horizontal. Height is horizontal, radius is vertical now. So the height is h, which is 1 minus x. Okay, so let's do one more example. It's the last example of this type. So let's do this one. Find the volume of the solid. Find the volume of the solid. Find the volume of the solid obtained by rotating the region bounded by y equal x minus x squared and y equal 0 about x equal 2. So let's pay attention to important ones. Bounded by these two curves and about the x equal 2 axis. So let's graph the situation again. So what it looks like. So x minus x squared, that's a parabola, upside down. It passes through 0 and 1. Okay, so that's the parabola. Passes through 0 and 1. 0 and 1. That's the parabola. And then what you can do, you're going to rotate this about the so that's the curve. So y equal x minus x squared, and you can rotate this about the x equal 2 axis. So right, x equal 2 axis. So that's the region you're talking about. So this is the region. You can rotate this region about the x equal 2 axis. That's the axis which passes through to x equal 2. So you can rotate about this one. So if you rotate about this one, it's going to go around it. So this is the region you get. So your region looks like so that's the original curve which was sitting here, and that's the 2. So you can jump to the other side. So it's going to be like that. Okay, so that's the region, and your cylinders looks like this now. So that's the, so you're gonna get the same axis of rotation. So that's axis of rotation. So you're gonna cylinders with the same axis of rotation. So we have like that. So that's how the cylinder looks like. So it's gonna go around. Go like that. Yeah, that's how it looks like. So what you want to do is we want to find the height. It doesn't matter, just pick whatever side you like. So let's go with this one because here we have all the information we need. That's the height, and we need the radius r. So the total distance is how much? 2. This is 2. And also this is, you're gonna pick a typical point xy. So this is gonna be the x coordinate. You can draw any you can pick any point, so it doesn't matter what side. But this is the part we know. Okay, so good. So the height is clear. So so the radius. So what's the radius? So let's find the information now. So the radius so radius equal what? Radius equal radius of the cylinder. So it's equal 2 minus x, right? So 2 minus x. That's the radius. So which is 2 minus x. What is x? Yeah, it's 2 minus x. So you don't want to, because it's a dx problem. So you don't want to convert this. Remember, like, you know, before you integrate, you have to convert this into one variable depending on the derivative integral. But here the thickness is on the x direction. Thickness is on the x direction. So it's a dx problem because this is dx. That's a thickness. This is a thickness, which is a dx. Okay, so it's a x. So that means everything has to be in terms of x. And the height. Height is what? Height is the y coordinate. It's simply the y coordinate, but you can have y. You have to convert, but y equal what? It is x minus x squared. So that means this is in x, this is in x. That means we have thing in order. So let's try the formula. It is 0. What is the x range of x? X changes from 0 to 1. So go from 0 to 1. That's where the x changes, 0 to 1. And then it is 2 pi. The radius is 2 minus x. The height is x minus x squared. And it's a dx problem. Everything in x, so that means you can integrate. How we do this? We're going to distribute first. So if you distribute, you're going to get x cube minus 3x squared plus 2x dx. You can integrate term by term. So if you integrate term by term, this is x4 over 4 minus x3 plus x squared. And then we put 1 and 0. And if you plug in 1 and 0, you end up getting pi over 2. Okay. Good. So so these are the typical questions that you can find. So so there will be about 6 questions, just to make sure that we're going to cover like different types. um, okay, so this is the shell method, uh, and this is the last topic that we need to study for the exam. So make sure that you go over these problems and completely understand first, and then you can move on to the homework. And also we have the tutoring session tomorrow from 3 to 6. So if you have questions, you can discuss with my TA. And also I'll be on Wednesday in the office hours, so if you have questions, you could just come by. Okay, so thank you so much, and good luck with the exam.